Hello and welcome back to 4.7, Solving Polynomial Equations. So today we're going to use the zero product property, which is something that you learned a long time ago, right? It says that anytime you multiply anything by zero, it will always give you zero. You use that a lot in pre-algebra and use some in Algebra 1. And so we're going to use that idea to set equations equal to zero. We'll factor them down so that you have things being multiplied together, and then if any one part of those equals zero, then the entire expression has to equal zero. And so then we can solve for our for our variables that way. So when we start off here, okay, we are going to look at this first problem. We have y squared plus 7y equals 18. So we need to get this set equal to zero. So the first thing I'm going to do is subtract 18 from both sides, and that gives me y squared plus 7y minus 18 equals 0. At this point, I want to try and factor this down. Now we're going to use those factoring rules that we've already learned. Okay, we know that this is y and y. Plus and minus means one's plus and one's minus. Since the first term is the same, it doesn't matter which one you put the plus and which one you put the minus in. And then what are the factors of negative 18 that give you a positive 7? Well, that would be a positive 9 and a negative 2. So now see how this turns into two things being multiplied together to equal 0. So if either one of those equals 0, then the entire expression does. So if y plus 9 equals 0, and if y minus 2 equals 0, if either one of those is true, then that means you're going to get 0 for your answer. So we're going to subtract 9, so y equals negative 9. Over here we're going to add 2, so that gives you y equals 2. So now if we write this in solution notation, we have 2 and negative 9 are our answers. When we move on to a question like number 2 here, same exact idea. We want to get it set equal to 0, so we're going to subtract 10r and 8 from both sides. So that will give us 3r squared minus 10r minus 8 equals 0. So again, we want to figure out how can we factor this down. So we know that 3r and r is the only way to get 3r squared. Now we have a minus minus, so that means we're going to have one plus and one minus. And it will matter where they go because our first terms are not the same. So what are the factors of 8 that can get us to 10? But we have to remember we have this 3 over here that we have to worry about. So if we put a minus over here and we do 3r times a negative 4, and then on this side we can use our plus 2s to get our negative 8. 4 times 2 gives us that 8. And then here, 3r times negative 4 is negative 12, plus this positive 2 leaves us that negative 10r. So now we just set each part of this equal to 0. Then we solve for r in each one. And so here we get r equals negative 2/3. And here we get r equals 4. So again, in function notation, in solution notation, okay, that would be negative 2/3 comma 4. Now remember, because you have the brackets instead of the parentheses, that's not a point. Those are just all solutions to your problem. Okay. Same thing with this next one. We need to get it set equal to 0 first. So we can subtract 10x from both sides. So x squared minus 10x plus 25 equals 0. And then we need to factor this down. Now, for some of you, you may need to go through and do it this way. Others may have noticed this as one of those, the perfect square trinomials, so you could go straight to x minus 5 squared to begin with. So what this means, right, since you have two of them, you have twice that x minus 5 equals 0. Now, you don't actually have to do it twice, but you need to recognize that it happens twice. So then we're going to add 5 to both sides, and you get x equals 5. But because that happens twice, this is what's known as a double root, okay, which is explained up above as well as in your book. So this is a double root, so let's put dr. And in my solution notation, I'm going to put 5, and I'm going to put dr. Okay, so that just tells you that, right, there's twice there, okay, that you have that x minus 5. Now those double and triple roots that you may see later on become really important, especially when you get into some of the applied calculus.
So here again we want it set equal to 0, so we're going to subtract the 36u squared from both sides. So u to the fourth minus 36u squared equals 0.
So if you remember back to our first discussion about factoring, right, we always want to factor out the GCF if there is one, and there is a greatest common factor here of u squared. So once we do that, we're left with u squared minus 36 equals 0. So then this is the difference of perfect squares. So you can very quickly write this as u plus 6 and u minus 6. Now we have this squared situation, right? So that's really u times u. So this is another situation where it's a double root. So this, right, we could have u equal to 0, which is the double root. We could have u plus 6 equals 0, or we could have u minus 6 equals 0. So we subtract 6 from both sides, u can be negative 6, add 6 to both sides, u can equal 6. So in our solution notation, we write it as 0, which is a double root, and then we have 6 and negative 6. Oh, got to get it on the screen. All right. So that covers our first 4 examples. Now if you flip it over, there are a few more. We have examples 5 through 8 to go over. Okay, with these ones, some of these are going to add another dimension to them that you guys haven't gone over before. Okay, so with this first one's very similar to the last one. So we'll subtract 8y, subtract 8y. So this is 15y squared minus 8y plus 1 equals 0. So we break it down. Minus plus means minus minus. The only way to get 1 is 1 and 1. So the factors of 15 that are going to add up to that 8 that you're looking for, right, are 5y and 3y. And then so just like before, we bring down that this equals 0. So if either one of these sections equals 0, then the entire problem equals 0. So 5y minus 1 equals 0, and 3y minus 1 equals 0. So we're going to add 1 to both sides. 5y equals 1, divide by 5, you get this 1/5. Over here, add 1 to both sides. 3y equals 1, divide by 3, and you get 1/3. So in solution notation, you have 1/5 and 1/3 for our answer. Number 6, they started factoring it down for you, but they didn't finish, right? That's the difference of perfect squares. So this is x plus 2 times x plus 2 times x minus 2 has to equal 0. So now, again, this is going to be a double root because I have 2 of the same thing. So I really only need to look at x plus 2 equaling 0 and x minus 2 equaling 0. And we just have to remember that this is the double root. So we're going to subtract 2 from both sides. X equals negative 2, which is your double root. We add 2 to both sides, and x equals 2. So our solution notation would be negative 2, which is the double root, and then 2. Okay, number 7 takes a while, okay, but we will get through it, right? This is really s minus 6 times s minus 6 times s minus 6. And then this has to equal this 27 times s minus 8. So we're going to just start multiplying all these things out. So s minus 6 times s minus 6 is going to be s squared minus 12s plus 36. And again, that's using, right, our squares here, our perfect square trinomial. And then that has to be times s minus 6 again. And then on the other side, we can distribute this 27 to get 27s minus 216. So if we multiply this out, right, we do s squared times s, that's going to give us s cubed. S squared times a negative 6 is a negative 6s squared. Negative 12s times s is a negative 12s squared. Negative 12s times a negative 6 is a positive 72s. Then we have to do 36 times s, which gives us a 36s. And then 36 times a negative 6 gives us a negative 216. And then we bring down the 27s minus 216. For me personally, I like to combine like terms. I think that's by far the quickest and easiest way to do this, and then we'll get it set equal to 0. So let's do some combining of like terms. Well, this is the only s cubed part, so we bring down the s cubed. When we have s squared, we have a -6 and a -12, which gives us a -18. There are no other s squareds, so we just bring down the -18s squared. Now we look at our s's. I have a positive 72 and a positive 36, which adds up to a positive 108s. And then we bring down the minus 216 equals 27s minus 216. We now have to get the problem set equal to 0. So now I'm going to subtract 27s, and I'm going to add 216. So when I do that, this side, right, totally cancels out, and we're left with equals 0. Over here, those cancel out. If I have 108s plus -27, that gives me 81s. And then I just bring down the rest of the problem. Now, right, we can factor out an s out of here before we do anything else. So this is just s times s squared minus 18s plus 81 equals 0. So here, this is a perfect square trinomial. So this is going to be s times s minus 9 times s minus 9 equals 0. So either s equals 0 or s minus 9 has to equal 0. We just have to remember that that's a double root, so we'll need to make note of that. So we're going to add 9 to both sides, and you get that s can equal 0 or s can equal 9, which is the double root. So again, our answer is 0, 9, which is the double root. All right, for number 8. Okay, this one is kind of an interesting one. You have this t minus 2 cubed, which means it's really t minus 2 times t minus 2 times t minus 2 minus t minus 2. So I can actually pull out a t minus 2 out in front. And if you pull that t minus 2 out in front, then on the inside you still have t minus 2 squared. And then here it's just minus 1 to hold that place. So when you multiply it back out, you get the t minus 2. So then this is t minus 2 times, and then t minus 2 squared would be t squared minus 4t plus 4, and then minus 1 equals 0. So t minus 2 times t squared minus 4t plus 4 minus 1 is 3 equals 0. So now I'm left to be able to factor this last part. T squared is t and t. Minus plus means minus minus, and the factors of 3 that add up to 4 are 3 and 1. So now t minus 2 can equal 0, t minus 3 can equal 0, and t minus 1 can equal 0. So now I just simply solve each one of these. So I have t can equal 2, t can equal 3, t can equal 1. So in solution notation, right, that's just 1, 2, and 3. So if you need to go back and watch that or pause that time to make sure you got it or you understand it correct, my apologies for if you couldn't see some of it. You can go back and take a look at it. Your homework is right here tonight. Good luck, and we will see you tomorrow.